Hello, my dear students, and the rest of the learners. Welcome to part 36 of a 37 series of tutorials in Computer Structure and Programming Unit in C and Pascal. This is section 2 of 2 in the topic File Handling. My name is MemGM, or you can simply call me EMELISWAP. In this tutorial, I'm going to look at the introduction. Then we are going to look at sequential files in terms of creating and opening those files, writing to sequential file, reading from a sequential file, checking for existence and end of file, as well as closing a file. And then we shall look at sample C and Pascal programs, implementing file handling operations, design an organizational file. And lastly, I'll look at what we call the random access files. Let's begin by introduction. There are various file handling operations that can be performed on files. These include creating a file, opening a file, reading data from a file, writing data to a file, as well as updating a file's content, amongst the others. So let's look at how we create and open files in C and Pascal. In C, this creating a file or opening a file is the process of making a file to be ready to be read from or written into. It is a process that is creating and opening a file is a process of making a file to be ready from or written into, whether in C, in Pascal, or in any other programming language. Before creating a file structure pointer has first to be declared using the following syntax. File, then file pointer. And then we can also declare another one called file story pointer. Each file, open file, must have a separately declared pointer of type file that is used to refer to the file. The file pointer is then assigned a pointer to the file structure for the file opened with fopen function. This is done through a statement, the following syntax. File pointer equals to fopen file full path name, comma, open mode. For example, fopen C:\dict fees.txt, comma, A. A is the open mode. The full path for the file, the full file path is C:\dict fees.txt. In other words, we are opening a file called fees, that is a text file called fees, that is stored in a subdirectory called dict, which is in the main directory or in the root directory, which is the hard disk. And fopen is the function for the same, and then we assign that to a pointer, that is a file pointer. Or we can also have it as follows. That is fopen C:\dict fees.dat or that, comma, W. W is the mode of opening the file. All the subsequent file processing functions after the file is opened must refer to the file with the appropriate file pointer. The file full path name is used to establish a line of communication with the file. Files may be opened in one of the following two modes. The first one is R, that is, or it means open an existing file for reading. W means create a file for writing. If the file already exists, discard the current content. A means append. Open or create a file for writing at the end of the file. R plus means open an existing file for update, that is reading and writing. W plus means create a file for update. If the file already exists, discard the current contents. A plus means append. So open or create a file for update and writing is done at the end of the file. Note that to change the above modes to become binary modes, we just add letter B to the first letter in the modes that I've already explained. For example, RB means open an existing file for reading in binary mode. WB plus means create a file for update in binary mode. If the file already exists, discard the current contents, amongst the others. So you just continue adding B to each of the modes that I have already talked about. So in Pascal, how do you go about it? The common syntax for declaring a file in Pascal is var file name, then file of file type. For example, var scores, file of integer. All, a file type can be defined and used to declare file variables, and therefore its syntax would be as follows. Type files, file of file type. Then variable var file name of type files. For example, type studrec equals to record with the following members: name, string of type string, age, type integer, and then student file equals to file of studrec. So file of studrec is of type student file. In other words, student file equals to file of student or studrec. So student file is our variable that we are going to use to manipulate the elements or the members of the file, which in this case is a record. That is file of studrec. Then we have a variable called student details of type student file. Of type student file. Student or student details is a variable of type student file. Let me repeat this part, my dear students and the rest of the learners, so that you can gain proper understanding. So you declare a record. Remember what we said about records and structures in my previous presentations on data structures. And we talked about record as a data structure in Pascal or a struct in C. And this is exactly how we are declaring them. So we have, remember, a file is composed or contains various files or various records. A file is composed of various records. And therefore, because the record or records are just multiplication or they are multiples of details in a single record, then we have to define or to declare a record. And how do we declare the record? It is, for example, if our record is called student, we declare it as type student equals to record, and then it has the following members: name of type string, age of type integer. And then we have student file equals file of student, because we are going to have a file consisting of the records that we have already defined under student. And therefore, we have to declare a file. Remember, this is a declaration. This is a declaration for the record. And a file is composed of several records. And therefore, after having defined a record, then we have to declare a file of type record. And therefore, in this case, we are saying that our file is called student file, and it is file of our record, which is student. And then to manipulate the elements of our file, then we need to declare a variable or an object or instance. That variable is called student details, and it is of type student file. So it is a variable that is going to be used to manipulate the various records in our file. In Turbo Pascal, files are assigned special names within the program. The assign statement is used for this purpose. The syntax for this statement is assign logical name, comma, action name. For example, assign student details, comma, fees.text. So the information after student details, after the comma there, that is the complete path for the file called fees, which is a text file. And this file is stored in a folder called DRCT in the hard disk. The actual name is the name provided by the operating system, while the logical name is the name used to indicate the file in all operations within the program. Files can be opened in any of the following modes. We have read mode, whereby the file can only be read from and nothing can be written in it. We also have the write mode. When the file is first created, it is opened in write mode and the data is written into it. Subsequent reading from the file in this mode does not destroy the stored data. So, to write to a file, it has to be opened in write mode. If the file already exists, it will be erased. Number 3 is called the append mode. This mode allows the data to be added to an existing file without destroying its previous contents. So how do we write to a file? In C, before data can be written into a file, it must be opened in a mode that can allow the process of writing to the file. Such modes include those that I initiated as, or I have explained as A, R plus, and A plus. Then any of these two functions can be used to write it to a file. fputs, which can be used to write a line to a file, and fprintf. It is the equivalent of printf that we discussed in C. Its syntax is printf, file pointer, comma, type identifiers, comma, variables. Remember, the type identifiers are in double quotes. For example, printf stood pointer. Then the rest of the part is for formatting the output, where admission number, which is an integer, is formatted to 7 spaces. Name is formatted to 15 spaces, and the fees is formatted to 10 spaces, the two of them being reserved for the fractional part. What about in Pascal? A file is opened in write mode in Pascal using the write statement, whose syntax is as follows. Write logical name. Of course, there is a closing bracket. There is a parenthesis for closing. This is an error. So it's supposed to be closed. And then rewrite stood details. Or for example, you write stood details. I have said there's a comma at the end of this statement before semicolon, not a comma, but parenthesis. So logical name is supposed to be enclosed in parentheses, just as you can see in the second statement. So stood details is the logical name for our file. Then the writing of data to the file is done using any of the following two statements. Put and put is used to write data to a file. So writing data to a file using this statement is done as follows. First, the data is moved into a file buffer using the statement logical name, then pointer to data. Then it is written to a file using the statement put logical name. Kindly note the syntax that we use. For example, stood details is a pointer to name. Stood details is a pointer to name. It can also mean pick the content of memory location code name and assign that to student details pointer. In other words, this is like initializing student details with the address or memory location address being pointed to by the pointer that we are calling student details. Then we have put student details. Let's look at write or write line. Data is written into a file using this statement as follows. Write logical name, comma. You list the items separated by comma. Everything, the logical name and items are enclosed in parentheses. For example, write logical name is student details. Then write what? Admission number, name, and fees. Remember, these are the members of our record. and therefore they are members of the records in our file. Then we can also use write line. I hope you remember the difference between write and write line. So write line, student details, comma, admission number, name, and fees. How do we read from a file? In C, data can be read from the file using the functions fgets or fscanf. Remember, to identify that we are reading from a file, we just add f to gets that we are used to, or scanf that we are used to when dealing with programs in C. The function fgets can be used to read a line from a file. The fscanf function is used just as a scanf function, but in this case, it reads data from the file instead of reading from the screen. The syntax for using fscanf function is as follows. The difference between this statement and the other statements for reading that we're making use of the function scanf is just that we are now adding a section for file pointer and a section and changing the scanf to fscanf. So if you remove the file pointer from this statement and you also remove f, you'll just be reading from the keyboard. And therefore, this is how we write the scanf statement in C. That is syntax for using scanf function when it comes to handling of files or reading and writing to a file. For example, fscanf, our file pointer is student pointer. Then our type identifiers are D for integer, S for string, %lf for float. In Pascal, read from a file, the file pointer is taken to the beginning of the file using the reset statement, whose syntax is as follows. Reset logical name. For example, reset student details. Reset student details. Then the reading can be done using either the get or read line statements. In the read statement, the name of the input file can be specified. If an attempt is made to read data from a file that does not exist, the program generates a runtime error and execution is halted. So, an error detecting mechanism should be integrated in your program. The syntax for the read statement is as follows. Read logical name, then items. For example, read student details, comma, admission number. When using the get statement, data is read from a file by stating the variable, then data that is used to receive the data, and the get command that is issued to perform the read function. So the syntax for doing this is as follows. Logical name, then pointer to data. Pointer to data. In other words, you can read this statement as pick the memory address occupied by data and assign it to the memory location being pointed to, or the memory location being pointed to by our pointer, which is the logical name. Then we have get logical name. For example, student details pointer to admission number, pointer to admission number. So student details is our pointer to our file, and it points to the admission number. In other words, we can say that this statement means pick the memory address occupied by, or the memory address for admission number, and assign it to the memory location, assign it the memory location for our pointer, which is student or student details. So this is a pointer. Student details is a pointer that points to admission number. Then we can have get student details. So how do we check for existence and end of a file? In C, you can use the if statement to determine whether a file is opened or not. For example, as follows. If stud pointer equals to f open followed by that file name and the mode, which is W. So if stud pointer is equals to null, if stud pointer, or if the file open, if the file open is equals to null, then display the following: file could not be opened, meaning that this statement is checking for the existence of the file. If that file does not exist, then another value is equated to the non-existence of the file, and therefore the message file could not be opened is displayed. In addition, the function FEOF can be used to check whether the end of file has been reached or not. This function is very important, especially when you want to read or write several records in a file. For example, in the following statement, the FEOF determines whether the end of file indicator is set for the file to which the pointer refers to. So here it is. While not end of file, stud pointer do the following: read admission number, and store it in the memory location being pointed to by stud pointer, and repeat that for as long as the end of file has not been encountered. The argument to function FEOF is a pointer to the file being tested for the end of file indicator. The function returns a non-zero value, that is true value, when the end of file indicator has been set. Otherwise, the function returns 0. Because data is read sequentially in a sequential file, if you want to reread a file after reaching the end of the file, you can inform the file pointer to go back to the beginning of the file using the function rewind. For example, rewind student PTR. Remember, in this statement, what we include is the pointer to the file. In Pascal, the end of line and end of file functions are extremely important in reading data from files. Since the number of data items that are present in the file cannot be known earlier, the only option is to read the file till all the records have been read. The end of file condition is returned by the function EOF. Similarly, if a text file is being read, the end of line condition is returned by the end of line function. These functions can be applied as follows. While not end of file, student details do execute the following statements. So let's now look at closing a file. Once you are through with performing a given task with a file, you have to close it. In C, the syntax for closing a file is fclose file pointer. For example, fclose stud ptr. So this function also receives the file pointer rather than the file name. If this function is not called explicitly, the operating system normally will close the file when the program execution terminates. This is an example of operating system housekeeping. In Pascal, the syntax for closing a file is as follows. Close file object. For example, close student details. Let's now look at how we design an organizational file. And in this context, I'm going to look at programs implementing files, handling operations, or programs that are implementing the various file handling operations that we have already looked at. So the following is a program in C implementing file handling operations. So we have our preprocessor directive there. We have our main function. We have a local variable called admission number of type int or integer. We have an array of char, which should not exceed 30 or size 30. Then we have a variable called fees of type float. Then we have a Boolean declaration called choice that has been initialized to Y or to yes character. Then we have our pointer to our file. So it is file pointer, file stud pointer. That means it's a pointer to our file. So how do we create, open, and write data to a sequential file? So we open our file called fees as follows. Remember the work of A at the end, that is the mode that we are opening our file in or with. And then we are using our pointer to manipulate the file. So we are assigning our address for the file to the pointer. So we are assigning the address of the file, fees or text file called the fees, to our pointer. And then we check this condition. So if the choice that has been entered is yes, that is Y. So if the content of memory location called the choice is equals to character Y in small or character Y in capital, that is in uppercase, do the following. Display the message, enter this student's admission number. Then read the animation number, and of course store it in the memory location called animation number. Then display the next statement. Enter this student's first name. Read that student's name and store that name in the memory location set aside called name. Then display the following statement. Enter this student's fees page. Whatever value that will be entered, store it in the memory location set aside called fees, which is of type double. And then we write the content of animation number, content of name, and the fees variables to our file, whose pointer is student pointer. So we write those three into our file, spaced as 7 spaces for animation number, followed by 15 spaces for name, and 10 spaces for fees, with the 2 of them being reserved for the decimal point part or fractional part. Remember the difference between this statement and our ordinary primitive statement is the addition of the F character, so that it reads as F primitive, and also the addition of our pointer for the file, like in this case, studPTR. Otherwise, the rest of the parts of the primitive statement remains as we are used to. Then we display the message, this record has been written to the file. Then we ask the user whether he or she wants to enter another record. So the user can press either capital Y, or it may even be small y, or capital N. Then the character entered, whether Y or N, is rendered and stored in memory location called choice. And once this brace is encountered, the check is carried out again. So the loop repeats, or there's an iteration to checking the condition based on what has been entered. If what has been entered is yes, that is capital Y or small y, then whatever is this block of statements will be executed again. If the user enters N, that is for no, then the condition will be checked. So while choice is not any of these two, the program will exit, or that loop will be exited. And then we close the file that is pointed to by studPTR or student pointer using the function fclose. So how do we open an existing file? And how do we read from it and display the content on the screen? So this is what will be displayed next. This statement will be displayed on the screen. The following are the student's fees status. We open the file that we have already entered data into and closed, which is fees file that is stored in the ARM disk. So we open it. And then we display the message, animation number, or we display the following headings on our screen: animation number, space, name, space, fees. Remember, escape sequence stroke N is an escape sequence character. T \T is a escape sequence character for spacing. So we also underline those headings using this statement. And then we check the following condition if it's not end of file. So if not end of file, while not end of file, pointed to by student pointer, do the following. So do this as long as the end of file is not encountered. So read the content, read or get the content, get the content, or get the following content, from our file. Remember, this is fscanf. So that means we are reading from a file. So read the current value of memory location called fees, name, and the admission number. In other words, the content of our record in our file, the members of our record, who are fees, name, and admission number. Pick the content that each of them is occupying or holding and write it. So in other words, let me rephrase this statement. As long as the end of file is not experienced or encountered, pick the following values. Pick the following values, or read the following values. Read the following values from the file: fees, name, and admission number. Then, after reading, display them on the screen. Display them on the screen. So display the content of admission number, formatted name, formatted, then fees, formatted, but with the 2 decimal places. In other words, what I'm calling formatting is the escape sequence T. It is for tab. So display the content of admission number, the screen, space, that is tab, then content of name, you tab, you space, and then fees. And that continues until the end of file is encountered. That means all the records will be displayed on the screen, and therefore the loop is exited, and then we drop down one character or one line, the screen. And then we close our file. We return the control back to the operating system and end our program. The following is a program in Pascal implementing file handling operations like the ones we have already looked at in C program. The only difference is change of the syntax. So our program is called sequence file. Then we declare the following item: uses for the purposes of performing various functions to do with our screen. Then we declare a record called student. So type student equals to record, and it has the following members. One member is called name, which is of type string, which will not exceed 20 characters. Then the other member is admission number of type integer. The other one is marks of type integer. Then end. And then we declare a variable called num and I of type integer, and another variable or object called results, which is of type student. Remember, this is the object that is going to be used to manipulate the contents of our record. And then we declare a file of type student. That is a file called dict1j, which is composed of records, which are name, admission number, and marks. So it is dict1j. So variable dict1j, file of student, or of type file of student. Then we begin, we clear our screen. We display the following message: program to create a sequential file of student data. And then we assign dict1j the following: marks.txt. So assign dict1j, then that is the full name for our file called marks, which is a text file. And then we rewrite DICT1J. Then repeat the following. Write out, enter the number of students, display that message, enter the number of students, then the value entered, and do that way until the value entered is greater than 0. So this part, my dear students and the rest of the learners, is simply meant to regulate, the number entered. So if, for example, you enter num as 50, the content of num will be greater than 0. So you don't repeat again requesting for the number of students, because already you will have gotten the number of students whose records you are going to store in your file. Then you do the following. Initialize ith1 to the value entered. For example, 1 for student 1 to 50 if you entered 50 students, or if you want to manipulate the records for 50 students. And then with the results, remember what we said concerning the with reserved word when it came to avoiding repetition of the object for manipulating the members of our record. So with the results, write the statement animation number, then read the animation number, display name, read name, display marks, read marks entered, and store them, of course, in the record through the object called results. Then write DICT1J results. So write results, DICT1J. Then end that. So by doing this, you have captured data for one student. Then after capturing, this statement is meant to transfer what has been read from the screen to the file called DICT1J. And then once this end is encountered, the for loop is incremented by 1. I is incremented to 2. Is 2 less than the num? If yes, you repeat the following. So this will continue. This will continue until the value of the counter is no longer equal to or less than num. So once it is more than num, the loop is supposed to terminate or end, because all the details for all the students will have been captured. Then we close that file using that statement. We reset the file, then we clear the screen, and then we now display the following on the screen. The results file contains the following. Remember, you are resetting so as to allow us to do the reading from the start. Then we display the headings, animation number formatted 10 spaces, name formatted 20 spaces, and marks formatted 12 spaces. We underline each of them formatted in the same manner. And then we check, while not end of file, the file called DICT1J do the following. So as long as the end of file is not encountered, read results. Read results from the DICT1J. So read DICT1J, comma, results. Then with the results, do the following. Write out this on the screen. Animation number formatted 10 spaces, content of name formatted 10 spaces, content of marks formatted 12 spaces for the first student. Once this end is encountered, you increment the counter, or you move up again, and you check again. If not end of file, you read next record. So that will continue. That will continue for as long as the end of file is not encountered. But once the end of file is encountered, you terminate the loop and close the file. and end the program. Let's now look at random access files. Individual records of a random access file are normally fixed length band, which may be accessed directly and thus quickly without searching through other records. This makes random access files appropriate for interactive and online processing systems that require rapid access to specific data. Because every record in random access file normally has the same length, the exact location of record relative to the beginning of the file can be calculated as a function of the record key. Fixed length records enable data to be inserted in a random access file while destroying other data in the file. Data stored previously can also be updated or deleted without rewriting the entire file. The best structure to apply when writing or reading data to or from a random access file is a record or a struct. It is good to initialize a file using an empty struct or empty record in order to create space on the disk in which the file will be stored and make it possible to determine if a record contains data. The following are some functions used in C when handling files. fwrite, it writes a block or specific number of bytes of data to a file. fread is used to read a specified number of bytes from a file to memory. fseek can be used to set the file position pointer to a specific position in the file and then use the fwrite to write data. So fseek can be used in combination with write. And with that, my dear students, we have come to the end of the topic, file handling. Congratulations for learning section 2 of 2 in the topic file handling. You can also access sections 1 of 2 for this topic, other topics in the computer structure and programming unit, as well as other computer or ICT videos by clicking or tapping on EMELISWAP ICT YouTube channel below this video. You can also visit EMELISWAP Life Skills YouTube channel for free life skills, motivational, and inspirational resources. To subscribe to the channel, tap on subscribe button below this video in YouTube if it's not currently reading as subscribed. For any further correspondence, kindly write it to us through the email emeliswap@gmail.com. Thank you very much for listening to me. Let's meet in the last part of this series of tutorials, which is part 7. God bless.